25 years ago, when I just started developing software.
Nexus provides us, for positioning system in harbor areas.
Technology does get better throughout the time.
Autonomous driving, embedded engineering.
How to make this multi-million lines of code project to be stable, to be maintainable.
But when we are dealing with the LiDAR sensor, we have to deal with, 3D information.
What is more important, hardware or software? Hello everyone and welcome to Singula Talks. My name is Grigory Petrov and our guest is Engin Bozkurt, CTO and co-founder of Beamz Lidar. Hello Engin.
Hello, Grigory. Thanks for having me today.
Thank you for joining us. Let's get to know each other. So, can you please tell us about your background in technology and what are you doing right now?
First of all, thank you for having me today, actually. My name is Engin Bozkurt. My professional background encompasses expertise in electronics, robotics, software engineering, and data science. I have actively worked and managed different projects actually on the autonomous driving, embedded engineering, robotics projects, and the LiDAR-based technologies across different global regions such as Europe, US, and the Asia Pacific. Currently, I am holding the position of Chief Technology Officer and the co-founder of Beamz Lidar.
What are you doing right now from the technology point of view? What are your clients and what are you doing for them?
Yeah, actually, based on our experience, we interact with different industry leaders, decision makers, and different clients. So we saw that with the full potential of LiDAR technology goes much beyond the automotive industry. So adoption in smart cities, LiDAR adoption actually provides automation, industry automation, and the security applications. And actually, we are trying to find the pinpoints and the inefficiency in the infrastructure of the different companies. So for instance, in speed enforcement, we realize that there is a need for accurate and reliable systems that can help to ensure the road safety and the compliance with speed limits. On the other hand, we explore partnerships and the collaborations with organizations in different industries to explore new applications or tailor existing technologies to specific use cases. By collaborating with stakeholders, we gain insights in the industry-specific requirements and adapt their technology accordingly. Our decision-making process for choosing technology applications targets involve a combination of proactive market research, customer engagement, technological innovation, and the capabilities and the strategic partnerships, actually.
For my next question, I will steer you towards some specific companies and application. So you can name a few like speed enforcement, other different applications, and we can continue to the next batch of question like how this technology can be applied. Okay?
Yeah. So, but I cannot give the exact names because
Yes. Of course, just what are called verticals in business, like industry verticals. So, Engin, for me as a software developer, leaders are autonomous cars, but for you, they are much more. So what are the major applications for this LiDAR technology that you do for your clients? What are they doing with your LiDARs?
the functional real-world applications and implementations of smart cities has been a driving force behind our product development strategy. So we saw that the LiDAR adoption has a full potential, out of the automotive industry, not just self-driving cars or autonomous vehicles. So by integrating with the stakeholders and different companies, and also by collaborating with, law enforcement agencies and the transportation authorities, we implemented speed enforcement platforms and also traffic management systems. And these platforms actually solve the problem of, traffic management, intersection monitoring, and also other different traffic management patterns and the challenges in the industry. Especially, the traffic management is very crucial in modern world and the urban areas. And this is our main technology stack, actually, speed enforcement platform and the traffic management system. And the other one is the LiDAR-based software perception platform is Persona. Persona actually provides a common platform for the human tracking and the crowd analytics. So we are partnering and working with the transportation hubs, port terminals, and where the LiDAR can bring a value and bring a value to enhance the existing infrastructures, or we are tailoring our technology stack into specific use cases. So the other one is the human crowd management systems. Another technology stack of the Beamz Lidar is actually 3D mapping system. 3D mapping systems allow, the robots or autonomous vehicles to navigate safely in challenging environments, such as like underground tunnels, mines. So it is giving, actually this groundbreaking technology is very crucial for the different industries like oil and gas industries and different, industrial plants for mission critical operations. The last our software technology stack is Nexus. Nexus is a port terminal automation system. Nexus provides us, for positioning system in harbor areas. For example, when truck enters to the crane, it's giving a valuable information to navigate the truck driver to reach the possible target in efficient way. This is the port terminal operations and for positioning of the trucks actually in harbor areas. So our main areas are this kind of technological, our main areas actually handling with this infrastructure harnesses and the challenges.
Wow, this sounds unusual and exciting. Of course, I know that my vacuum cleaner has some LiDAR technology inside, but I never thought about it at that scale. We at Singula team, as outstaff company, we help our clients with different projects, and I even know about some hardware projects with mechanical hands, with mechanical hands, with some advanced software solutions for them. But of course, hearing this from a person who is deep within this industry is interesting. And
that's my pleasure. Thank you.
Let's talk a little more about this speed enforcement application. What are the traditional solutions in this area, and what exactly do you improve with LiDAR technology?
Grigory, actually, in traditional speed enforcement systems, camera and radar sensors are using, not LiDAR. But we followed a different approach to, disrupt all the existing technologies. So especially when you are using the camera sensors, they have so many limitations because, as a nature of the camera sensor technology, the sensing mechanism of the camera sensors actually, they are integrating with just the resulting image, not with the physical phenomena like light or fog or snow. So it is dealing just with resulting image. So this brings, some limitations based on the light and the weather conditions. So they are very susceptible to weather conditions and the light conditions. On the other way, radar also is generally used for speed enforcement systems. Sure, yeah, actually it excels in speed enforcement like LiDAR, but it's lower resolution and other some, the cons of the radar technology. It disqualifies as a viable product for intelligent transportation systems, even as the radars. So because of that, we are optimizing these challenges with the LiDAR technology. LiDAR provides 3D information for in every condition, like a snowy, foggy, or like, in the harsh light conditions. So we are processing all these challenges with our 3D perception software platform and giving actionable insights to the law enforcement agencies and the authorities too.
Yeah, this sounds like a really new technological way to do things. And how fine-tuned are your solutions to the specific clients? For example, you have mentioned speed enforcement and traffic management, and for me, they both sounds very similar. How much of your technology do you reuse between different applications?
Actually, sure, you can use different modular stacks for different applications. But when we are, for example, in enforcement systems, we can say that, for example, traffic management system is focused on the traffic optimization, intersection monitoring, and the traffic patterns detections. But speed enforcement systems, whereas speed enforcement systems just focus on, the speed detection and the vehicle tracking. So because of that, when we are following the modular technology stacks of Beamz Lidar, sometimes we are using the common modular stacks for different applications. But mainly, when we interact with the industry, we are learning so much things from the client side, because they are giving us, valuable information about the challenges of industry specific problems. So we are optimizing our system based on the inquiry of the requirements of the client and different industries.
So at least something in this new, modern, bright technology resembles the technology I'm most used with. At Singula team, we of course do lots of different things, but we excel at admin panels, CRM, ERP system, like things that businesses use to administer things. And this LiDAR technology and its applications are amazing. So these human detection systems that you have mentioned, they are a controversial topic due to all the privacy questions. I do remember our clients who do privacy related work like GDPR, data anonymization, and all these things. They are important and there is a huge demand for them. So what are the benefits of this LiDAR technology in the area of privacy while doing human detection?
Actually, yeah, it's a great question, Gregory. Modern days, sure, the anonymity and the privacy concerns are actually very essential. In the sense of the LiDAR technology, actually, the LiDARs detect the humans and other objects not intrusively like the other sensors, like a camera or radar. Actually, it is just generating some kind of pixel image, it's not including the facial features or some kind of biometric data. So the LiDAR technology actually provides, data security concerns and the privacy concerns efficiently. For example, when you are trying to detect the people or the objects, when you are using other sensors, it detects the facial features or other individual data and it's recording. But LiDAR-based crowd management and the human detection systems, you are not tracking any kind of facial feature or some human appearance. You are just detecting and tracking the movements of the people, their shape and size, and according to that you are providing some output for the different systems, just for efficient management of the crowds in crowded areas like transportation hubs or port terminals or any kind of airport, in this kind of crowded facilities, some concert areas, or such as like this kind of places actually.
25 years ago, when I just started developing software myself, we called these things voxel clouds. And now I can see this technology application outside of computer games or some 3D modeling.
You are so right. Actually, the LiDAR generates a kind of image like that voxelized thing, like old games, in the 1960s like that. So you cannot detect the facial features of any person. So it concerns all privacy issues. So because of that, Persona and LiDAR-based our human crowd management platform is compliance with the data regulations like in Europe, GPDR, General Data Privacy Regulation, and also CPR in the US, California State Privacy Act. So it's concerning all this data privacy and the data regulations actually.
Some of our open source project at Singula team are related to these privacy issues. For example, we do some database tools and utilities for software developers so that they can download anonymized data that they can use for their software development locally without seeing any real customers' data. But of course, if data is not there, like in LiDAR technology, it cannot be compromised. And that's great.
So as you mentioned, when you are dealing with the privacy issues, yeah, you are post-processing some things and you are regarding these issues. But in LiDAR technology, even in the raw LiDAR data, you don't get any, private data. Just some kind of a voxelized image, some pixels, that's it.
Among the different applications of this LiDAR technology stack, you have also mentioned the mapping system and navigation for warehouses, tunnels, mines, which reminds me about my vacuum cleaner that every day crawls around my house and tries to keep it clear. So with vacuum cleaner, if it goes awry, I can just lift it and put on track. But for some big autonomous robot in a tunnel or a mine, it's a completely different story. And from your experience, how accurate can these systems be if self-driving cars with the same technology, let's be honest, crash regularly?
Actually, you are right. Yeah, we heard news, some self-driving and autonomous vehicles crashes. But, when you are analyzing this kind of challenges in autonomous or semi-autonomous vehicles or self-driving, actually, we have to analyze different things, not just the technology itself. For example, when we are working with our LiDAR mapping system, because we are working, with the construction areas or underground mines, and these environments actually very specific places. So they are not like a very wide area, you cannot deal with like a real world roads and the highways. So these places actually very structured And also even they have some parking, some marks, some beacons, some pre-routes. So when you are dealing with LiDAR mapping in warehouses or industrial facilities, you just have to deal with the, some limited conditions. So it gives you more precision and accuracy in your systems actually, not like in the real road. But as the technology evolves and all this, the 3D LiDAR perception systems evolves, these things getting better, just to reach the real-time systems and the safety of the, all pedestrians and the other environmental elements actually.
Technology does get better throughout the time. I do remember that 15 years ago, when Singula team just started, we were focused on Ruby backend development, and now we help our clients with Python, Go, with some hardware projects and data anonymization projects, lots of them. So, of course,
I want to mention one issue, especially in the underground mines and the, tunnels, there are very strict policies for the regulations. So even you have to deal with these policies, your systems is very controlled with these policies. So you don't have to deal with the real world jungle, in these areas actually. So because of that, we are adjusting and tailoring our technology stack into these limited conditions. So it gives more accurate and precise management for us.
Let's talk about the software development topic, which is, of course, more natural to me as a software developer. You mentioned that traditional camera systems are two-dimensional, while LiDARs are three-dimensional and more like a cloud of dots or voxel cloud than an image. So how does this difference affect your software development, what you do differently, and what are your main challenges for your development team?
Yeah, that's a great issue actually. That's our bottleneck and the big challenge. Because when you are dealing with the camera sensor, you are just dealing with the two-dimensional information and the data. But when we are dealing with the LiDAR sensor, we have to deal with 3D information. So this brings additional challenges for processing raw point cloud data, which is generated by LiDAR sensors. So because of that, also the huge data, actually the LiDAR sensors generate huge amount of data. So, and also you are dealing with the noisy data. Because of that, we are developing pre-processing systems to deal with the noisy data and also deal with the computational efficiency, because you have to process all this big amount of data in short time to reach the real-time system performance. So we are filtering the noisy data. At the same time, concurrently, we are downsampling the whole data. So we are dealing with the small amount of data in the real time, filtering the noisy data. At the end of the day, you are just giving the required information for different industries and for different authorities in different sectors actually.
These are different kinds of challenges that normal developers face. For example, our ordinary challenge at Singula team when we help our client is how to make this multi-million lines of code project to be stable, to be maintainable, so new features can be implemented in time frames, timely and accurately. Yeah, and with LiDAR technology, different. It is different. And what about your technology stack? How different it is from, let's say, a typical machine learning image classification tasks that lots of developers do, that we do in more traditional areas of software development?
Actually, in traditional machine learning and deep learning models, generally you are dealing with some supervised or unsupervised systems, and also you have some annotated labeled data. But especially in LiDAR, For example, you are doing some segmentation of the different objects in 3D scene. You have to deal with some pre-processing techniques, some modular stacks, along with some traditional feature engineering in AI. So we are integrating all this approach together. So we are following a hybrid approach. So we are actually this is a combination of traditional software development and traditional AI data-driven systems. So one of our stack is working on AI-driven, data-driven systems, and the other one is working on the traditional software and the pre-processing techniques, such as like a geometric processing.
Yeah, that's great. And one more question about the software side of things. With traditional software development, we have a lot of existing tools and libraries. As a Ruby developer or Python developer or Go developer, I rely to open source libraries and frameworks and millions of lines of code that are already written by experienced developers. But in your area of expertise, how different it is? Do you have a lot of ready-made things that you can utilize, or do you create lots of things from scratch?
Actually, yeah, this is a great question. There are many pre-trained data sets in LiDARs, but actually they are tailored for the self-driving and autonomous driving. So our focus on intelligent transportation systems, speed enforcement, and the human crowd management systems and the LiDAR mapping. So for the different industry needs, to meet these specific requirements, we have to create our own benchmarks from the scratch. We have to create our data set and to collect the data set, then we have to process it. Sure, also the LiDAR community is starting to, generate new benchmarks, new data sets, but this is like a new area. And as you could imagine, in this big infrastructure projects, you need teams, in different disciplines. This is a multidisciplinary works it requires. So because of that, when we are working and following our modular stack, we working with the different engineers in robotics, AI engineering, feature engineering, data science, and also, just LiDAR processing systems. So this requires actually, the multidisciplinary work actually. But sure, sometimes we are trying to leverage existing frameworks, but this is very limited. So we have to do many stuff from the scratch, indeed.
You have mentioned benchmarking and optimization. LiDAR technology is different from our traditional software development. For example, when we develop some website or admin panel or enterprise resource management for our client, the code that we write, it is being executed by servers in the cloud, and the loads, hundreds of thousands requests per second, can be evenly distributed between dozens of servers. So everything is fast and scalable. But for LiDAR technology, you have physical devices, you have physical places where you need to manage traffic. And I can assume that you cannot offload all the calculation to the cloud. So, do you do all the calculation on end devices? And if so, what is the amount of data per second that you need to handle for all these tasks?
Actually, Grigory, you pointed out a nice challenge issue actually. When you are working with the physical sensors, you are limited time and you cannot work every time. You cannot just mount or LiDAR sensor on the intersection. You cannot always collect the data because there are many different scenarios and different issues to deal with your AI data-driven system or traditional software development techniques. So because of that, actually, we are creating our own simulation environments, and based on our tailored benchmarks, we are trying to understand the challenges and the inefficiencies for different tasks and the processing. Even that when you are dealing with the traditional software, if your client is asking for different thing, you have to change your whole mindset. So just forget about, apart from the LiDAR-based techniques, when you are dealing with the new industry, new clients, you have to tailor these implementations based on the requirements of the client actually.
Yeah, this is indeed the big challenge, and sometimes even bigger than our high load in the traditional backend development industry. And one more difference that I have noticed with machine learning and AI and computer vision, lots of companies work together, cooperate, and share their results. So machine learning engineers are not left alone. They can search and rely on the best practices. How about your industry? Are there any pre-trained ML models available, maintained open source libraries, maybe even strategic partnerships across major players?
Actually, yeah, this is a great point. It's a great question. Actually, establishing strategic partnership with different organizations across various industries, it's very crucial for us because, it gives you some resources, some actionable insights. And for example, by collaborating with the law enforcement agencies and the transportation authorities, also we are learning the regulatory landscape because you are working with the public infrastructure, so you have to follow the regulation domains and the verticals. So that's actually strategic thing, the establishing strategic partnerships with different organizations. And as you mentioned, for example, when we are dealing with the different industry needs, such as like the oil and the gas industry, you have to concern all safety regulations. So because of that, we are working with the industry leaders, decision makers, the clients to get the feedback and to tailor our own technology stack into specific use cases.
In this area, maybe the hardware industry is more mature compared to our traditional software development, because I can see that, yeah, we have this GDPR regulation, some patchwork regulation, but in general, the software development right now is a wild west. Sometimes we are called to help clients who have already lots of software created, and sometimes they are ruins because no regulation exists, and no one can actually check that software is of good quality, maintainable, and can really handle the job at hand. Let's talk a little bit about the future of this technology. Of course, I know that bragging about the future is something, but still it's interesting to speculate a little bit how our area of technology may look like in 5, 10, maybe 20 years. So what are your best prospects for the future of the LiDAR technology and your business perspectives?
Especially when you started to talk about the LiDAR technologies, you mentioned that when you heard the LiDAR word, this just gives an idea about the self-driving cars and the automotive industry. So based on our interactions with these clients and industrial leaders, we realize that the non-automotive LiDAR adoption will be game changer in the following 5 years and in the future actually. Because when you are dealing with the different infrastructures, and the different facilities or interacting with the different law enforcement agencies, you can see that the existing sensors and the frameworks actually not very efficient for real-time applications. So the LiDAR brings a value for real-time processing systems indeed. So because of that, when we are approaching the clients in different industries, we are always concerned that, okay, which problems can we solve with the LiDAR? Or this LiDAR technology, even when the LiDAR sensors start, there were just mechanical LiDARs. But now they are transforming from solid-state LiDARs, FCR LiDARs, and the FMCW LiDARs. So there is a big trend, in the chip technology. And also the maturity of the 3D perception systems brings additional value. Because actually, when you are dealing with the LiDAR sensor, the raw data gives you just good information. But honestly, it's useless without a 3D perception software because it doesn't give any idea about some actionable insights. So, and also the maturity of the 3D perception systems on software side, along with the different technologies in the hardware and the chip development, it will bring, additional use cases for real-time systems.
Yeah, software is eating the world. That's
exactly.
why
We are saying LiDAR
it.
is eating the world with software. That's a good
Yes,
motto.
with software, and as far as I know, custom machine learning and artificial intelligent software in the heart of your system is one of your values of your business that you offer to your clients. By the way, in this area with LiDAR and all the applications for it. What do you think? What is more important? Hardware like better leaders, more expensive, more fine-tuned, or software that process all these 3D point clouds and detect things and measure things and create maps and everything like that? How are they related to each other? What is more important?
Actually, it is a combination of more, actually both hardware related and the software related issues. But the chip technology actually could reach some level, and and also it waits for the better softwares, right? Even in the camera or using radar, the software, as you mentioned, it's all the sectors. So the better the maturity of the 3D perception systems brings additional value for different use cases. So I can say that, the LiDAR based perception softwares brings so much many values for the real-time implementations of this whole areas like speed enforcement, traffic management, crowd analytics, and even in the security applications, intrusion detection, perimeter security. So all these areas actually happens with the better softwares actually, not the better hardware. Sure, the hardware brings so much value because you are dealing with this data at the end of the day, right? But if you don't have proper software solution for different use cases, you have just a LiDAR sensor. You cannot do anything.
Yep, that's it. And talking about LiDAR sensors, there are some obvious weaknesses of this technology. Out of the blue, I can suggest that they are expensive. And by the way, how important is it that individual LiDARs are expensive? What is the approximate part of this LiDAR cost in the entire setup? Is it like the majority of the cost, half of it, or just a small part? How is it important that LiDARs are expensive for now?
Actually, you mentioned a great issue. Actually, there are two issues in this, the cost-effective systems. Sure, we are dealing with engineering projects, right? So there should be some cost-effective concerns. But for some projects, when we are dealing with the accuracy and the reliability, sometimes you have to discard, the expenses, right? Because at the end of the day, you want to reach the level of reliability, accuracy, and the precision, especially when you are dealing with the digital infrastructure of the urban places, urban environments, or the traffic and the highway environments. But on the other way, for example, when you are dealing with the human crowd management systems, your other alternative is the camera sensors. But you have to deploy and maintain many camera sensors for tracking people on a big, large facility. But with LiDAR sensor, maybe you can just use one or just one couple of LiDAR sensors and that's it. So it's giving you, additional cost-effective solutions in some setups and some different industry use cases. So it depends on the project actually. Sometimes, yeah, sure, the cost is big, but it brings additional precision, accuracy, reliability, and the robust system. But sometimes, even you compare to camera sensors, it doesn't bring additional cost actually. Even sometimes less affordable, more affordable than the camera sensor.
Yep, analyzing different opportunities is at the core of the business. And for our clients, they also check every time, do they want to contract software developers from us, or do they want to search for them on the open market? And sometimes it's better to take people from us, or sometimes it's better to hire them directly. There are lots of options available, and good businesses takes the best possible actions. So I think that concludes our interview for today. Are there any other points or topics that we didn't talk about yet and want to record? What do you think?
Actually, I really appreciate it for giving a chance to, explain this additional technology advancement in LiDAR technology and the LiDAR-based software technology. So we mentioned many issues, the hardware issues and the software issues. And actually, I'm so happy to working, speaking with you, especially you are dealing in your daily work with the different clients, different industries. So we have some common challenges when even we are dealing with the AI-driven, data-driven system or traditional development. The same challenges when you are trying to enter a market or different industry branch and the sectors. We have some common challenges and issues to handle with that, and we have to concern privacy regulations and also even, as you mentioned, the bias of the people, right? They are looking very suspiciously into self-driving cars or autonomous driving. So you have to break this ices in the industry. But this is a mutual trust, the people, if they are thinking like that, okay, these guys are transparent, they are trying to do something new, groundbreaking technology, we can give them a chance to try it and make some minimum viable product and make it like some pilot project for different use cases, so you can show the real potential of any kind of technology, not just LiDAR.
Indeed, indeed. Thank you, Engin. That was Singula Talks with our guest, Engin Bozkurt, CTO and co-founder of Beamz Lidar, and our host, Grigory Petrov, a developer relations at Singula team.
It was so nicely and friendly chatting and discussing with the LiDAR technology with you. I appreciate that. Thank you.